So now I'm trying to make a video during video game club, which might not work at all. May just be way too loud, but at least you can see what I'm doing. Load, delete. Okay, so I'm gonna just make something up. So first I'm gonna do it by hand. And we have on our chi-squared notes here, we have this made up thing about blue eyes and brown eyes. Apparently nobody in this story has green eyes or hazel eyes, but I'm going to make it light eyes, dark eyes, light hair, dark hair, and I'm going to make stuff up. So the way you calculate chi-squared here is exactly the same as the way you did before. So we have the expected values in kind of every slot, and that's determined by this divided by the total times how many there were in that category. So let me just make this up then. So I'm going to do light eyes, dark eyes, and then light hair, dark hair. And normally we go ahead and write the expected value right there in that column too, but I don't want to do that because it'll look like a train wreck. So I'm just going to give myself a little space to put it over here, and we'll pretend like we'll make that a box. Guess this is something I could have done prior to recording, but oh well. Okay, so I'm going to pretend, oh, so this is total. Hello. I'm going to say that we had, I don't know, I'm going to say n is 60. It's not really relevant. I'm just using that to kind of guide myself here. So I'm going to say that the number of people who had light eyes total was 20. No, that's not very likely. How about 17? So the total number with dark eyes then is 43. Okay, so I'm going to say the total number with light hair was 22. And I'm going to say, I guess I shouldn't copy and pasted that. The number of people with light hair and light eyes, let's say, was 13. So that means that the dark hair people that with light eyes was 4, and 43 minus 9, 34. Okay. Yeah, look at that. Thought I had quit that. Okay. Okay, so now our expected values would have been, so light-eyed people with light hair, we would have 22 times 17 divided by 60. Basically because we have a 17/60th chance of having light eyes times 22 people, or we have a 22/60 chance of having light hair times 17 people with light eyes. So this is going to be 17 times 20, oops, times 22 divided by 60. And this one is going to be 22 times 43 divided by 60. Here our expected will be 38 times 17 over 60. And here we'll have 38 times 43 divided by 60. Okay, so our sum of squares is going to be C3 minus B3. I may be doing these out of order, but it doesn't really matter because once you square it, it's the same thing. But I do have to make sure that I divide by expected. So divided by C3 plus, now I need C4 minus B4 squared divided by C4 plus. And now over here, expected minus observed, observed minus expected, D3 minus E3 squared divided by expected E3 plus D4 observed minus E4 expected squared divided by E4. Okay, so this is really not sum of squares, this is really chi-squared. These are some loud kids. Okay, that's pretty large, but we've got a 2 by 2. So our degrees of freedom is 2 minus 1 times 2 minus 1 is just 1. So if we look here, where did that chart go? My goodness. Here we go. Whoa, whoa. Degrees of freedom 1, 3.841. So that's actually pretty small. The higher your degrees of freedom are, the more kind of leeway you have. So we've got this 16.2 is way bigger than 3.841. So we would reject the null and say these are not independent of each other. I think it's pretty clear they're not. I've made them so they weren't. So we would reject the null and say that lightness of hair and lightness of eyes is not independent, but rather is dependent. Okay, so that's how we do it by hand. Of course, by hand, you'd have to really write it out. So I'm going to show you how to put this in a calculator. I might just stop there to save this so that I don't lose everything. I'll close this out. Oops. I don't want to save that. Okay, so I'm going to go here and I'm going to insert a matrix. So this is for a matrix. And we're not going to put the totals. So basically it can calculate the totals itself. So we are just going to put 2 by 2. We're just going to put in the number of people in each column here. Move this closer to me so hopefully you can hear me over these hoodlums that are yelling. Okay. So I want a 2 by 2 because I have 2 categories over here and 2 over here. If I had separated it into blue eyes, green eyes, brown eyes, blonde hair, brown hair, black hair, then we'd have a 3 by 3. So all you put is these four values: 13, 4, 9, 34. Okay, and then I want to store this. Oops, I don't think I can undo. Gotta put it back in again. Oh well, now you can see it twice. So 2, 2, 13, 4, 34, 9, and then store, and we'll name it A. You can name it whatever you want. Okay, so now this is called A, so if I click A, I get the matrix back again. Now, go to statistics, go to tests, and right here, the chi-squared two-way test, that's the test of independence. And it's asking me what I want, so I'll choose A. And now it gives me this chi-squared, which you can see matches the one that I got from doing it by hand. Degrees of freedom is given. This gives me a p-value, which again, I can't get on a chart, so it's a little more important. The thing that we're missing here is these expected values. So if I needed to answer what the expected was, I'd be in trouble. You can see it kind of wants to be here, but it's not showing it. So what I'm going to do is I'm going to go to variables, and down here I have expected matrix, which currently is being assigned to this thing I just did. And then I just hit enter, and now it gives it to me. So there's those values from there. So if I needed to show written down all this stuff, I could get it all from the calculator, except I guess the totals. And then of course chi-squared would have to be written out. Okay, so this is how to do the test of independence, both by hand and on a calculator. And again, this is when we've got two different categorical, which is also qualitative variables that we're trying to check the independence of them.